Hello and welcome to the Discover Breathing podcast. I am Chris Dyan and I'm joined today by my co-host, Featherington.
And we'll be speaking to two lecturers from our Biomedical Sciences department, Dr. Simon Clarke and Dr. Dyan Sellayah, and they'll be speaking about how their research overlaps with understanding COVID-19 and also their thoughts on living a healthy lifestyle, which is obviously more important than ever at the moment.
All right, so first of all, Dan and Simon, if I could get you to introduce yourselves to our listeners and explain who you are and what you do. And if I can start with you, please, Dyan.
Thanks, Chris. Hi, I am a lecturer in the School of Biological Sciences, and my research is focused on obesity, and specifically looking at how maternal obesity during pregnancy can program metabolic status in offspring.
I am Simon Clarke, Associate Professor in Cellular Microbiology and Head of the Division of Biomedical Sciences and Biomedical Engineering. And my research focuses on the pathogenicity and carriage of the MRSA superbug, but I also comment a lot and take a view on the COVID pandemic.
Perfect. So yeah, just to start off, if you could sort of talk us through the COVID virus, how it works and how it is different to other coronaviruses, just so we've got a sort of basis to carry on from there. And Simon, would you be best placed to sort of start with that?
Probably, I guess. So coronaviruses are a group of viruses that have these little spikes that stick out from the surface. And when you look at them down an electron microscope, it looks like they've got a crown around them. So hence the term coronavirus. And those little spikes that stick up from them stick the virus to the cells in your body. And coronaviruses usually infect in human beings the respiratory tract. Now, we've all had a coronavirus infection because there are 4 of them that are pandemic in the human population, and they cause the common cold. So we'll all have had at least one, probably more than one of those. You may also have heard of SARS and MERS. SARS is the severe acute respiratory syndrome virus, and MERS is the Middle East respiratory syndrome virus. And they, over the past 20 years, have caused a couple of outbreaks. Nothing like COVID, but this relative of SARS, which we now call COVID-19, or that's the name for the disease, not the virus, started circulating in China towards the end of 2019. That's why it's called COVID-19, coronavirus disease of 2019. That's COVID-19. It has spread from China around the world, and as it's done so, it's continued to evolve. There have been a number of steps in its evolution which allow it to spread better and cause more severe disease. So that's happened basically over a year now. It's only something we're really giving a lot of thought to. But the secret of its success is that it is very able to jump from person to person. It's very transmissible. And that's really what's caused the problem. When it gets inside your body, invades the cells in the lining of your airways, or the lower parts of your airways, it replicates. That's what viruses do. The ambition of a virus is to become many more viruses. And your immune system responds, causes an inflammation, and that can cause in your lungs, in your airways, a buildup of mucus, which means it's very difficult for you to breathe and get oxygen into your blood. And it also stimulates immune reactions around the rest of the body that can cause all sorts of other problems.
Yeah, I think that is the perfect summary. And now, building upon that, if we could ask both of you how your research overlaps with COVID, and if I'll start off with Dyan.
The short answer is not directly, actually. But what we do know about COVID is that people who are obese are more likely to die of COVID-19. And so mortality rates are positively correlated with body mass index, which is a measure of adiposity, or how much fat you have. And so my research focuses on obesity, looking at how, at the molecular level, how one could either prevent obesity or reverse it, and also looking at the genetic basis for it, and also how it may be programmed during pregnancy, as I mentioned earlier. So I think with regard to COVID, my interest is strictly to do with obesity and trying to prevent or trying to reverse some of the mortality associated with obesity that we see with COVID-19 patients. And I guess we can go into a bit more on that connection, on that link later on in the podcast.
Yeah, definitely will. And Simon, you're a name that probably will be quite familiar to some of our listeners. So how does your research and expertise overlap quite neatly with COVID?
Quite generally, I mean, my interest is how your body responds to infection, and I have done a lot of work, certainly in the past and possibly also in the future, with a colleague of Dyan's and mine, a chap called John Gibbons. And we've looked at how infection affects your blood's ability to clot. And as we're hearing a lot now, COVID-19 can stimulate blood clots to form inappropriately. That blocks your circulation and stops blood and oxygen getting to tissues. But there is now also a concern with how a vaccine might cause that. And we think that's probably down to some sort of immune reaction that's causing that, some sort of inappropriate and sort of mistaken immune reaction, if you like.
That's something, obviously, a lot of people have concerns about that. Is that something that, do you think those concerns will be addressed kind of soon, or be an ongoing thing?
People are working very hard on it. They'll get the answer first. They need to, in order to be able to address it. You've got to know what your target is if you want to step in and stop that from happening. So there is an awful lot of work going on with this at the moment. So I expect there'll be an answer, hopefully sometime this year.
Is there actually a difference in terms of blood clots between the different vaccinations? Is there a difference? For example, does AstraZeneca cause considerable more blood clots than, say, Pfizer, or is it pretty similar for the different vaccines?
It's impossible to say. I mean, they're all very rare. For starters, we don't actually know what the occurrence of these is in the general population, so that makes things difficult. You've also got to remember that data taken for AstraZeneca vaccine will be taken in a different way. The studies will be done in a different way to data from Johnson & Johnson vaccine. So making a direct comparison really isn't very helpful, but it's important to realize that in fact the blood clotting that seems to be associated with the vaccine is very rare, and you're far more likely to get a blood clot from a COVID-19 infection than you are from a vaccine.
Yeah, I think that's a salient point, and sometimes, not to mention any tabloids, but something which maybe could be mentioned alongside much of the chat with the vaccines. That you're far more likely to get blood clot from COVID, and so personally, I'd rather have the jab. Thank you very much. Phil.
Yeah, so just to go back, Dyan, to a bit of what you were saying about your research, we wanted to ask you, so do you think sort of genetic factors have played a part in how people have coped with the COVID-19 virus?
And I think that is a good question, and I think Simon could probably go into this in more detail. But as far as I'm aware, most of the studies that have addressed this directly, there is little evidence actually that there is some genetic susceptibility that at least explains the majority of cases of mortality related to COVID-19. However, there are some studies that have shown from genome-wide association studies that there are some causal variants which are supposedly involved in predicting mortality, although I say causal with a pinch of salt, because these are merely associations, and so the causality is inferred, although this has to be confirmed by follow-up studies. But certainly there is evidence that at least one of the variants, and these are variants that are inherited together, they're called haplotypes, and there's some evidence that the haplotype that is associated with COVID-19 severity has been inherited from Neanderthals. So there is some evidence that these are archaic human genes that have been passed on to the modern human genome. And so genome-wide association studies certainly suggest that there might be genetic factors involved. We know that certain ethnic groups are more likely to die from COVID-19, such as South Asians and people of African ancestry. And there is actually evidence that these different ethnic groups have differences in terms of the prevalence of these Neanderthal or archaic human genes. So certainly South Asians seem to have more Denisovan ancestry. And actually the haplotype that is associated with increased COVID-19 severity is at higher prevalence in South Asians. And so, certainly there is some indication that genetics might play a role. We do know that obesity has a large genetic component to it as well. And as I mentioned earlier, obesity is very much associated with COVID-19 severity. And so you're much more likely to die of COVID-19 if you are obese. You're much more likely to be hospitalized as well. It is clear that genetics plays a major role in whether you're obese or not. The other thing is some ethnic groups seem to be more susceptible as a group as well to obesity, and therefore more susceptible to the comorbidities of obesity, such as cardiovascular disease and diabetes. And we know, and Simon will tell you, that diabetes and cardiovascular disease are both major risk factors for severe COVID-19 disease. So while the studies so far have suggested that socioeconomic factors are more prominent in terms of the contribution to COVID-19 disease and mortality, certainly genetic factors are likely to play a role as well.
Okay, that's great.
And one that was quite popular at the present in terms of trying to protect yourself from COVID, and I think Dr. Fauci in the United States has spoken about this, but many others have as well. It's a little bit of a disputed topic, but it's vitamin D and vitamin D supplements and natural vitamin D from sunlight and the impact that can have upon your immunity and likelihood of catching COVID. Is there actually something in the science which says that if you take vitamin D supplements or if you get plenty of vitamin D from the sun, that's a good way of preventing COVID? If I start off with Dyan and then go on to Simon.
I'll have to defer to Simon on this because my knowledge on this subject is not very high. So
basically, no. You've got to remember that with vitamins, you see in the supermarket these rows and rows of vitamin supplements. Most people are not deficient in any vitamins at all if they have a normal, healthy, balanced diet and don't need them. So as with many of them, vitamin D is a case in point. If you already have enough vitamin D, taking vitamin D won't have any effect. If you're deficient in vitamin D, you're probably going to be unwell in other respects as well, and that the same is true of other vitamins. So if you think you're at risk and you think you're vitamin D deficient, then for your own peace of mind, take a vitamin D supplement. But if you think that sort of ramming lots of vitamin D down your neck is going to protect you, the answer to that is almost certainly not.
Okay, there we go. Loud and clear. I mean, I guess, some people are arguing for it over winter because it's harder to take in vitamin D from direct sunlight, obviously, in winter. Is that true, Simon, or is it you can still get vitamin D in winter?
You will take in less vitamin D from sunlight, but it's in your diet as well. It's not just the sunlight thing. So again, if you're eating a healthy, balanced diet, then you'll be okay. You should be okay.
And the other thing, Chris, is that you'll notice that India currently has a major wave, and it's one of the sunniest places in the world, isn't it? So,
exactly, as is Brazil.
Brazil as well.
And I recall the United States, I think, had a terrible second wave in the summer.
Across the south of the United States, places like Florida and California, and they're not dreary.
Definitely so. So if that is much in terms of the immediate situation, with a little bit of a look ahead to, I guess you'd say, the short term, and then also the longer term as well. So, first question, how much of a concern are the new variants? Obviously, viruses mutate all the time. They can mutate quite quickly, but there's all kinds of, worrying headlines about the South African variant, most recently the Indian variant, and obviously in terms of their ability to go and evade the vaccine or a recent infection. How much of a concern are they, and how concerned should people be, do you think? Simon?
I think people should be aware that they can be a problem, they could be a problem, that we're not out of the woods entirely with this yet, but they will keep coming, and worrying about it is not going to stop that. And we've also got to remember that there are many more variants out there circulating in the world than we know about, because most countries in the world do not have the facilities to monitor what variants are circulating in their population. The UK probably is number one in the world for that, leading by some margin, even other developed countries. So large parts of the world where there is no surveillance at all, or barely any, we will continue to see them come from, and there may be variants that are circulating in those countries that will rear up and bite us soon. I mean, if you look at official figures for viruses circulating, places like Somalia are on the red list, but they have some of the officially lowest infection numbers, or lowest viral infection numbers in the world. So they're on the red list. So that's a tacit admission by authorities here that there's an unrecognised problems in countries like that.
One thing, just to go back to what you were saying earlier, that I found quite interesting, was about kind of the immune system and how that's really, really key in terms of how COVID can play out in people. And it made me think of kind of long COVID, and if you two had any kind of views on research into what long COVID is and what the effects of that are. And
so I mean, the effects of the immune system and the damage that it does during an infection, when it's trying to resolve an infection and get rid of it, is common in infectious diseases, bacterial and viral diseases. Quite often, I think it's probably fair to say most of the time, the damage done to you during an infection is actually done by your immune system. People assume that these bugs chuck out toxic molecules and that damages to you, and that does happen. But more often than not, I think it's down to the over-exuberant immune response, which damages you. So long COVID, we don't see that with other infectious diseases. So there is something special about it. Although you do get, having said that, you do get post-viral fatigue sometimes, but I don't think it's there. It tends to be as pronounced and as varied in terms of symptoms as we're seeing with, or perhaps as common as we're seeing with COVID-19 and long COVID. There has been some skepticism in the medical profession, quite a lot. But of course, plenty of doctors and nurses have also had COVID-19 when they picked it up at work. So fortunately, there is a sort of a powerful and knowledgeable body of people who can push back against the more skeptical members of their professions. So we'll see what happens with this. But at the moment, really, it's just a bunch of theories. And of course, the damage done by the immune system is a possibility, and people have been shown to have all sorts of internal damage when you look at them with a CT scan or an MRI. So that's presumably damage done by the immune system.
And Dyan?
Going back to the previous question about, how could we be more prepared? One thing could be to try to become healthier and fitter as a nation, because at the moment we're the sick man of Europe, and you see that sort of line everywhere. In terms of mortality rates with the virus, well, partly because we're one of the most obese nations in Europe, and we certainly have a lot of diabetes and cardiovascular disease, and so attacking that, I think, is going to be a key thing. And I think looking at what the government is saying, in terms of living healthy and eating healthy and exercising, I think they've seen obesity as a key step in trying to overcome the challenge of COVID-19, which is great because scientists like me have been banging on about obesity for a long time, but it's just never been given that much prominence in terms of an immediate health threat, because people always say, oh well, I'll lose weight when I'm older, when my cardiovascular disease risk is high. In your 30s and 40s, you sort of go with the flow and sort of not pay that much attention to your health, and until you get to your sort of middle age, and then that's where people, obesity rates are very high, and that's where obesity causes these metabolic disorders and diseases such as cardiovascular disease or liver disease. And so I think for the first time people are starting to cotton onto the fact that if you're a normal weight, if you're a healthy weight, then that can prevent you from getting not only COVID-19 but other comorbidities of obesity which impact on COVID-19.
Definitely. I think I had COVID back in November, and afterwards I definitely felt that kind of, I'm not immortal. I need to probably think about my health and take it a bit more seriously.
Yeah.
I wouldn't describe myself as kind of overweight or anything, but I definitely fitted into that bracket of being a bit kind of 30s to 40s and just thinking, oh, I'm fine at the moment, it's nothing can touch me. But it did make me think.
And for the first time you see young people dying of COVID-19 because of obesity. It does really send alarm bells ringing.
Yeah, and I have to thank Mr. Joe Wicks. Little shout out there for boosting my fitness over lockdown. Okay, and just as a quick contrast, I'm a big mixed martial arts fan, etc. Watching it, not competing myself, but I noticed one of the main fighters. He's a very talented young man called Kobe Garbrandt, and he got COVID. Obviously, now he's in complete and utter peak condition. He's 29 years of age, I think, and he ended up being sick for months, really. He got double pneumonia in both lungs. He was still testing positive for the virus a couple of months into infection. But one thing which he did say and remark upon, which is interesting, is that at the time of infection, he was preparing for a fight. And so therefore, he believed that his body was quite run down. He tried to rest for a week, and then he tried to get back in the gym and exercise as hard as possible. Is how you act when you have COVID, even if you're young, is that important? Is it a mistake to, if you want, like with quite a lot of infections, not rest properly and try and exercise, let's say a week or so after infection? Is it important to try and just basically shut down your body and just completely rest for a week or 10 days? Or does that not make much impact at all?
Being physiologically stressed will suppress your immune system, no question. So not smoking, not drinking, eating properly, resting properly are all things you should do if you're feeling even slightly under weather. In all infectious diseases, if you think you might be at risk, there is no question that those things are not good for your overall health. But we all do them, or many of us do them.
Yeah, I mean, us academics, we sort of function on 2 or 3 hours sleep a day, don't we, Simon?
Yes.
The other thing is overtraining and sort of the lack of fat, because we mentioned that the having a lot of fat is bad for you in terms of COVID-19, but you need to have a certain amount of fat because a lot of the vitamins are stored in fat, and they're obviously important for augmenting the immune system. And so I think it's clear that people who are below a certain threshold for body fat percentage are also more susceptible to disease, simply because they're not maintaining sufficient fat reserves. So low fat levels can also depress the immune system.
Yeah, a lot of this stuff is very sort of Goldilocks, not too hot, not too cold. Getting it right. It's like going back to the vitamins. There's no point, no reason to overdose yourself with vitamins, and it's similar to this. It's no point in overdoing the fat loss. Would you agree with that, Dyan?
Definitely, yeah, and so you basically you have to regulate that to within a small degree. Otherwise, it's gonna end quite badly. So, but that's the challenge, isn't it? Because being able to maintain anything within a certain range requires a lot of discipline, and so it's not easy, especially as a young person. You know, you sort of, the onus is on fitness and health, but then not overdoing it is something as well.
Great. So I think we're going to move on to talking about how COVID's sort of different to other pandemics that have happened in the past. And I think,
Sure.
Chris, I know that you've been reading a book about the Spanish flu, or the influenza pandemic of 1918, that you've got lots of insight from.
A book a day, I think, doesn't he?
He does, yeah, one of many.
Yeah, so this was I recommend it's by John Barry, written in the early 2000s. It was a fascinating book, and I think he called it the Great Influenza. Correctly, didn't call it the Spanish flu, because as he outlines, it definitely didn't really originate in Spain. I mean, I'm unsure, Simon and Dyan, how much you necessarily know about this pandemic, but one thing that struck me when I was reading it was just how terrifying it was as disease. I'm from a history background, rather like Phil, and probably one of the under-talked about parts of history is pandemics. I mean, in this one, at least 27 million people die globally. You know, you have people, young troops who are in peak condition, returning from the First World War, tragically dying in their 20s, young nurses who, you know, heroically try to save people, again, dying in their 20s. So it probably was the worst pandemic, if you want, of the 20th and 21st century. However, there's lots of different theories as to why it was so bad. From it comes down to treatments, it comes down to, you know, the situation in the hospitals, etc. And obviously that was a influenza outbreak as well, and that influenza pandemic is essentially what our governments had planned for in the years prior. So if we take this pandemic and if we go and compare it to the 1918 pandemic, and if you go and compare it, I think there was a bad flu outbreak in 58 and then again in 68 as well. How does it rank compared to these? Is this something which is, if you want, is a mild to medium pandemic, or is this something which is actually quite a severe disease outbreak?
This is a severe disease outbreak, and I think it's probably only comparable with the post First World War flu. You're quite right to say we shouldn't really call it Spanish flu, because that's just where it was first reported, I think. But it's difficult to make comparisons, even with the one in the 1960s, because we've become progressively more mobile. Healthcare has become better. We understand human physiology better. We understand the viruses better. Certainly, if you compare this outbreak to the not Spanish flu one, there were no antibiotics, and I'll come on to that in a minute. And we couldn't ventilate people, or not necessarily with an intubation type, sort of tube down the throat, unconscious ventilation, but this CPAP, this continual pressure that is used quite successfully. And like I say, also, we didn't have antibiotics then, and people will say, oh, well, antibiotics don't work against viruses. No, they don't, but they do work against the secondary bacterial infection that you're likely to get. So, and work quite successfully, because with influenza, when people die with that, usually what's killed them is a secondary bacterial infection on their lungs. And there will be some of that with this as well. So people are getting quite high, or have been getting quite high doses of antibiotics, and that will have saved some people. So all of these factors sort of add up to mean that you can't make direct comparisons. Now, if you did sort of manage to make some calculation where you could say, well, the 1918 pandemic was as bad as the current pandemic. Think about if you removed all those medical interventions. Does that mean the pandemic now would be even worse? And I suspect it does.
It's linking in a bit with the 1918 outbreak of flu, is if you guys think we'll see another pandemic like this or on this scale within our lifetimes.
I think that as mankind encroaches in on nature, this is a zoonotic disease, so an infection that comes from animals into humans. They will become more and more likely, and as we see urbanization of parts of the world, they will become more and more likely. And inevitably, because we like to live in a very connected world where we all fly around the place, we don't sail around the world in ships and take months to get from one continent to the next. Stuff like this is more and more common. It's ironic that we've got more ways of treating these infections, but it seems that they've almost outpaced that. We will face over the coming years a growing problem with antibiotic resistance, and there's every opportunity for another pandemic. Remember, this is the third coronavirus pandemic in the past 20 years. So, yeah, I would say there's a good chance that we will see something again within the next 5 to 10 years.
Yeah.
Okay. So it looks like COVID is here to stay, but I'd be interested to think, do you both think maybe come late summer that we will be at a point of normality and there will be more freedom?
There will be some normality and freedom, but I think for the next few years, I don't think there will be a lockdown in this country anyway, or I might be wrong about that, because I think we've got a sufficient handle on it. Unless, of course, there really is a big jump in terms of susceptibility to vaccines and post-infection immunity. I think much more likely we'll get sort of on and off controls and closing down of indoor environments. So you might find that supermarkets and gyms can only have a certain person density in them, or if you go to the cinema, you have to leave a radius of 2 meters or so behind you and anybody you're with. Stuff like that. I don't think we are beyond all the controls that could rear up, but lockdowns I think are less likely.
It's good to hear.
Good to hear.
Yeah, isn't it?
Yeah. So that's a somewhat positive note to end on. So just like to thank my co-host Phil. Thank you so much, Dyan, and thank you very much, Simon, as well, for your time this afternoon.
That was a fantastic chat with Simon and Dyan, sharing a lot of their knowledge about some of the biggest questions about COVID. I feel really lucky to have had their expertise and heard all their answers to our many questions. So yeah, what's next on the podcast, Chris?
So next up, Phil, is Dr. Mark Dallas and Professor Gary Stevens from Reading School of Pharmacy to talk about vaccines and therapeutics concerning not just COVID, but a variation of other diseases as well. And Phil, question for you, how can our listeners engage with us after today's podcast?
So if you just check the show notes for this Spotify episode, there should be different social media handles on there where you can get in touch with us, and also a link to our inquiry form as well if you've got a very specific question.
Perfect. Thank you so much for joining us, guys, and have a nice day.